Okay, so in the last class, we discussed about fin efficiency, which is defined as a ratio of heat lost with fin heat lost uh, with fin if the entire surface of the fin is maintained at base temperature. Okay, so next fin effectiveness. From fin effectiveness, we know that from fin effectiveness whether putting of fin is useful or not, and we have solved some numericals. In today's class, we will solve some more numericals. First one, a cylinder of 5 centimeter diameter and a 50 centimeter long is provided with 14 longitudinal straight fins of 1 mm thick and 2.5 mm height. You have to calculate what is the heat loss from the cylinder per second if the surface temperature of the cylinder is 200 degrees Celsius, and they are given H is equal to 25 watt per meter square Kelvin, thermal conductivity is equal to 80 watts per meter Kelvin, and ambient temperature that is a surrounding temperature 45 degrees Celsius they have given. Now this is a case of a fin with convection from its end. Okay, they have not told whether it's an insulated fin. Okay, so definitely it will be a fin with a convection from its end. Now the problem, they have told that there is a cylinder of 5 centimeter diameter. Okay, I have shown you the figure also. This figure has been given for you to understand. This figure has not been given by the problem. It is for, I have drawn for this for your understanding. So you can see that this is a diameter 0.05 meter, and the length of the cylinder is 50 centimeter. Okay, around the circumference of this cylinder we have attached 14 fins. Here I have shown you for one fin, the dimension for one fin. Okay, and actually it has been given few fins, but actually there are 14 number of fins. So in the problem they have told how many fins? They have told no 14 longitudinal fins. Okay. See, the length of the cylinder is becomes the width of the fin, and height they have told 2.5 mm height, that will become the length 0.0025 meters, and this is the thickness of the fin which is given 0.001 meter. So when they have given thickness and width or length height, okay, that means it's a rectangular cross section. The fin is a rectangular cross section, and the surface temperature of this cylinder they have given 200 degrees Celsius now, that is T naught. That will become the base temperature, and they have told 14 fins with thermal conductivity of the fin is 80 watts per meter Kelvin, that has been given, and outside ambient conditions H has been given 25 watt per meter square Kelvin, that is heat transfer coefficient, and also ambient temperature to be as 45 degrees Celsius. Right, this is the cross section area. Yavado width into thickness is the cross section area. Okay, this cross section area has been attached to this fin. W into T represents cross section area of the fin. That area has been attached to the cylinder, and in the problem they have told there are 14 number of fins like this. There are 14, here I have shown you very few fins, but there are 14 number of fins, okay, with thermal conductivity as 80 watts per meter Kelvin. And height of the fin will become length of the fin. Length of the cylinder is the width of the fin. This you should understand. Remaining, just put the formula. So cross section area is given by width into thickness. 0.5 is the width, thickness is 0.001. Okay, then you can get the cross section area as 5 into 10 to the power of minus 4. Perimeter, you know, the formula for perimeter is 2 times width plus thickness. Just put the values for W and T, get the value of perimeter. It will be 1.002 meters. Next, you know, M is given by square root of HP by K times AC. So it will become square root of H they have given no 25, perimeter you have found 1.002, thermal conductivity also has been given in the problem 80, cross section area you have found 5 into 10 to the power of minus, so that is what I have put here, 5 into 10 to the power of, then m will be 25.025 per meter. Next, for rectangular cross section, okay, I have used corrected length. As I told you, for a fin losing heat at its tip by convection, okay, you are going to use a formula for heat transfer of insulated fin, and you are going to use corrected length. For a rectangular cross section, corrected length will be length plus thickness divided by 2. 0.0025 is the height of the fin or length of the fin, plus thickness is 0.001 divided by 2, 3 into 10 to the power of minus 3. Next, heat transfer from each fin. You find out for each fin, then you will multiply with 14 fins. That is a total heat transfer by all the 14 fins you are going to get. Now, heat transfer through a fin is given by square root of HP K times AC tan hyperbolic LC. I have used LC, corrected length. I have told you, okay. I have used heat transfer for insulated end with corrected length. Instead of L, I have used LC, okay. Next, you are just substitute the values. H is 25, 1.002 is a perimeter, thermal conductivity is K, 80, cross section area is 5 into 10 to the power of minus 4, then theta naught is nothing but T naught minus TA. Okay, 200 minus 45 tan hyperbolic M 25.025 into LC is 3 into 10 to the power of minus 3. So heat transfer you are going to get 11.626 watts for one fin. And in the problem they have told there are 14 fins. Just multiply 14 into this, you are going to get total heat transfer for 14 fins. It will be 162.77 watts. Next, we will try to find out what is the heat transfer from the unfinned surface of the cylinder. That means, see, between the fins there is some area. Okay, through this area also heat will be transferred by convection. It will be transferred by convection. First, let us try to find what is the total area of this surface of the cylinder, then minus, okay. So this is the cross section area of the fin. No, the cross section area is the area attached to this cylinder. So cross section area, first you find, how will you find cross section area? W into T. Okay, how many fins are there? 14 fins. Okay, so total surface area minus 14 into cross section area of each fin will give you the, what is the area of the unfinned surface. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸೊ ಫಸ್ಟ್ ನಾವು ಟೋಟಲ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಆಫ್ ದ ಸಿಲಿಂಡರ್ ತಗೋತಾ ಇದ್ದೀವಿ. ಅದಾದ್ಮೇಲೆ area of all the fins we are going to subtract. Then you are going to get what is the area of the unfinned. This is the unfinned, right? So that you are going to find. So area of the unfinned is nothing but, you know, area of a cylinder is pi dl. ಇಲ್ಲಿ pi d L ಬದಲು width of the cylinder. Actually W ಅಂತ ನಾವು ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀವಿ, otherwise it is length only they have told in the problem. Pi d into width, that is the length of the cylinder is 0.5 meters, minus number of fins into cross section area of each fin, that is T into W or W into T. So just substitute, get the value of area of the unfinned surface. This will be 0.0715 meter square. Next, heat transfer, you know, it will be transferred from the unfinned area by convection. So apply Newton's law of cooling, HA delta T. So H into area of the unfinned surface into T naught minus TA, that is temperature of the base minus ambient temperature. Substitute the values, get the value. It will be 277.21 watts. Okay, next, so you can, in the problem there was what is the total heat transfer. So it is given by summation of heat transfer for 14 fins plus heat transfer of the unfinned area. Okay, so it will be 439.987 watts. That is 162 you have obtained no here that I have taken plus 277.21. You are going to get 439.987 watts. Right. Next problem. So determine the thermal conductivity of a long solid 2.5 centimeter diameter rod. One half of the rod was inserted to a furnace with while the other half was projecting into air at 27 degrees Celsius. Okay. So after steady state had been reached, the temperature at 2 points were measured. That is 7.6 centimeter apart were measured and found to be 126 degrees Celsius and 91 degrees Celsius respectively. The heat transfer coefficient over the surface of the rod exposed to the air was estimated to be 22.7 watt per meter square Kelvin. So you have to find the thermal conductivity of the rod. So in this problem they have told that you have to find the thermal conductivity of a rod having diameter as 2.5 centimeter. In terms of meter it will be 0.025 meter. Okay, and they have given the ambient temperature 27 degrees Celsius, that is TA, and they have told 2 points temperature were measured, that I will show in the figure, and heat transfer coefficient also they have given 22.7, correct? No, so you can see here 22.7 watt per minute, that is H. So okay, this is a problem of a long rod, very long rod, infinitely long. That case we are going to use, we will use those formula and get the value of thermal conductivity of that rod. So this is a figure. Okay, you can see here the at 2 points the temperature were measured. They have told, no, this is at point A and point B. At point A, that is, they have told it is 126 degrees Celsius. At point B, 91 degrees Celsius, and the distance between these two points is 0.076 meters. And also shown H and TA, 22.7, TA as 27, diameter also they have given. Okay, you have to find the thermal conductivity. Okay, see the starting point. Okay, see it's a infinitely long, and we are going to use the temperature distribution for infinitely long rod. Okay, before that, okay, I have taken point A as the, since it's a very long rod, I can take any point as the origin. Okay, I have taken point A as the origin, so I can take the temperature at point A as T naught, 126 degrees Celsius, and temperature at some distance, that is from this point 0.06076, that is x is equal to 0.76, the temperature will be 91 degrees Celsius. Okay, so try to understand. I have taken point A itself as the origin of the fin, and that will become the base temperature, that is T naught 126. At distance x, that is at 0.076, the temperature will be Tx will be 91 degrees Celsius. So you know the formula for temperature distribution for a infinitely long fin. It is given by T minus Ta by T naught minus Ta equal to e power minus mx. Now I have simplified this formula for m by applying natural logarithm on both the sides. I have applied natural logarithm on both the sides, ln of this, ln of this. Okay, so left hand side ln this temperature ratio, ln of E by E to the power of minus mx. Okay, idu nimge gottide, ln log A to the base A is 1. Similarly, ln E, base of the natural logarithm is also E, so it will become 1, minus mx into 1 will become minus mx. So what is m? M will be ln of this divided by x. Okay, so I will apply ln natural logarithm on both the sides, illu ln. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ log a to the power b ಅಂದಾಗ b log a ಅಂತ ಹಾಕ್ತೀವಿ. ಅದೇ ತರನೇ ln e to the power of minus mx ಅಂದಾಗ minus mx ln e, ಹೌದಾ? ಓಕೆ, ಬೇಸ್ ಏನಿರುತ್ತೆ ನ್ಯಾಚುರಲ್ ಲಾಗರಿಥಮ್ e. ಸೊ log, from logarithm, log a to the base a equal to 1. Similarly, ln e to the base e will be 1. So minus mx into 1 ಬಂದ್ಬಿಟ್ಟು it will become minus mx. So what will be m? Ln of this divided by x with negative sign. That is what I have written this formula. Okay. Other things, just substitute the values. You know, Tx is 91, Ta is 27, T naught is 126. That is a temperature at point A, minus Ta 27. That is a ambient temperature, divided by x 0.076. You are going to get the value of m, 5.74 meters. And next, you know that m is equal to square root of hb by k times AC. So perimeter will be pi times diameter. Okay, you know formula. Okay, pi d. You know the value of diameter. Just get the value of perimeter p. Cross section area is, since it's a circular cross section, the fin is having a circular cross section. We are going to use pi d square by 4 for finding the cross section area. So we are going to get 4.908. Okay, and this formula has been simplified for k. You know, m square is equal to hp by k times AC. Correct? I square root ikkade bandaga idu m square, it will become m square is equal to hp by k times AC. So what will be k and what will be k? It is nothing but hp by m square AC. Correct? No? So square, if you remove the square root, it will be, this will be m square. So what will be k? hp by m square AC, right? So just you know, all the values, substitute h they have given 22.7, perimeter you have found, AC you have found m square. Okay, 5.74, that is this value, 5.74 square. Substitute, get the value of thermal conductivity. It will be 110.87 watts per meter Kelvin. Okay, these are the references I have used while preparing this module. Okay, thank you.